No, no, this is your work.
Sure, Nick. Sorry? Sure, Nick.
I can do that.
Sure.
Anything else today?
All right, welcome to the SecDispatch Working Group. This is not your intended destination. This is your last time to get off the plane. This is the note well. Note it well. You should have seen this at least a couple times by now, but these are the rules governing your intellectual property rights and IETF contributions, so you should be sensitive and comply with them. Administrative tasks, blue sheets are circulating. One of Rich Sauls and Joe Hall's volunteer. Joe Hall is going to be our Jabber scribe, and Rich Sauls and Jeff Hodges have kindly agreed to be our note takers, so thank you for that. Reminder of our dispatch process. We are here to dispatch things, not to actually do work. So we're going to have some presentations about proposed new work for the security area, and we're going to decide what to do with that. We might drop that into an existing working group. We might have a new working group to handle this. Often a pretty focused working group to get a specific piece of work done. We can recommend that that an AD sponsor this if the ADs are willing, and we can kick things out for additional discussion or say we shouldn't do work here. So that's kind of the spectrum of possible outcomes we have here. So keep those in mind as you're hearing these presentations for proposals of new work, because we're going to try and decide on one of those for each of the pieces of new work that's proposed today. So here's the agenda. We have 5 things proposed for discussion today. We'll try and make a dispatch decision about each of those. Any agenda bashes at this point? Okay. Oh, of course. Sorry about that. I would like to introduce, are we at the end of our slides here? Yeah. So as one final item of chair's business, I would like to introduce our new chair. You may recognize her as our former security AD, Kathleen Moriarty. So let's have a round of applause to welcome her in. And Eliza,
give the speech as the stepping down chair.
Yes, and I'd also like to thank Roman for all his hard work as co-chair over these last couple of years. And much as I'm sad to see you go, I'm happy to see you step up as AD. So thanks again for your service. Yeah. All right, and Miles, is he in person or remote? There he is. Okay. So Miles, I think if you can join the queue, I should be able to give you speaker power. Okay. Okay.
Hello, is this working? Am I heard?
Okay, thank you.
Is the audio working?
Yep, works fine. You can go ahead.
Perfect. And I'd like to note right now that I'm joined in remotely by Micah, who is another one of my co-authors. So at certain points, he may also want to interject. I'm not sure how we'll get that to work. Thank you to the chairs for giving us this time. Today, we'd like to speak about key lists, which is our proposal for a system to distribute open PGP public key identities across large organizations. So if we could go to the next slide. Thank you. So the problem that we're trying to solve is that large organizations typically need to keep their potentially tech illiterate employees' internal key stores up to date across all devices. At the place that Micah and I work, we use PGP for email and for other purposes too, such as code signing. And we have a lot of people coming and going all the time. So keys are frequently added or updated, and not all keys' identities or the emails associated with them correspond to one single controlled domain. So we have certain employees whose preferred keys correspond to a Gmail email, others MIT, others the Intercept. And so existing solutions such as web key directories aren't always workable in our organization. Next slide, please. So in an email to the OpenPGP mailing list where we've had some existing discussion, One of the Micah wrote, one of the main purposes of keyless is to reduce the amount of work required to ensure that everyone in an organization or anyone who wishes to communicate with that members of that organization have the correct public key for everyone else. So really, the purpose of the key list is to ensure that a certain number of keys are constantly kept up to sync in the internal public key stores of either members of that organization or people who'd like to communicate with those people. Notably, we are not distributing the keys themselves. We are just distributing pointers to those keys, currently in the form of key fingerprints, which then allows the clients to leverage existing open PGP key distribution systems such as key servers or even web key directories to actually pull the public key content. Next slide, please. Thank you. So our solution is that organizations publish what is effectively a list of public key fingerprints in the form of a signed key list. If someone would like to subscribe to that key list, their PGP client will refresh and or import all of the keys on that key list at a user-defined interval. And that would be set up for certain employees when they are onboarded, for example. And the result of this would be that users automatically have the latest version of their colleagues' public keys. This is a system that is currently actively in use at First Look Media, The Intercept, and the Freedom of the Press Foundation using a tool called GPG Sync, which Micah is the author of. It's completely open source. And it works incredibly well, at least for our use case. Next slide, please. So this is an example of a key list. You'll notice that there are a number of metadata fields and that it resembles some sort of key store. So you'll note that a key list is signed, and that is an important element. So every key list can be authenticated with an authority key. So for example, the tech administrators at an organization have full control over the key list, but individuals can still push updates to their keys without having to change the key list and ask the administrators to update the key list. So the actual keys themselves remain in full control of the original owners, and the tech administrators just ensure that every other person in that organization is constantly updating those keys. Next slide, please. So there has been some discussion as to whether this is actually suitable to be an internet standard. And it's an absolutely valid discussion. This is very much sort of an application discussion. But the reason why we'd like to turn this into some form of internet standard, whether it would be experimental, is still absolutely up for discussion, is that we want multiple PGP clients to be able to import and subscribe to the same key lists. Right now, GPG Sync only interfaces on top of GPG, and lots of other PGP clients, especially those that exist on mobile, currently cannot be used with key lists. So what we'd like is for there to be a single format, standardized format for key lists that allows other PGP clients to subscribe, whether they are traditional clients such as GPG or newer mobile clients such as, for example, Proton Mail. Next slide, please. We've also gotten a fair amount of discussion as to why not such and such, why not such and such. And really, key lists are trying to accomplish something else. So to speak briefly to web key dictionaries and X509 PKI, we don't, with key lists, want to actually manage the distribution of keys themselves. We want to keep the actual keys in control. We want to keep ownership of those keys and control over those keys in the hands of the actual key owners. So what key lists do is it simply points to the keys, and then individuals can push their own updates to key servers themselves. So that's one fundamental difference between those two existing systems. And then finally, GNU-PG keyrings. So the same as above apply. And also, as far as I know, Micah pointed this out, GPG keyrings are not actually an internet standard. And so keyrings for GPG2 are incompatible with keyrings for GPG1. And one final thing to note about why web key dictionaries, for example, do not work in this case is that all of the keys fall under different domains, not all of which are controlled by the central administrator. So key lists allow an organization to distribute keys across from several different domains within an organization, even if they don't themselves have control over those domains. Next slide. I spoke about this briefly earlier, but this is a system that is not just a theoretical prototype. It's implemented by GPGsync, and it's been in active use in First Look Media, The Intercept, and the Freedom of the Press Foundation, with collectively probably more than 300 employees for the past 2 or 3 years or so. So this is a system that has been sort of tried and true within our organization, and that other organizations are actually looking to potentially use themselves. Next slide, please. There are a number of areas that we'd like to further develop. So we're considering adding a well-known location, and there's some discussion over this as whether this is potentially a security vulnerability because the authority key needs to be inputted separately, but that is a discussion for elsewhere. We would like to consider additional functionality for key lists. We'd like to better analyze the potential security implications, do general improvements to our draft. You may know that Micah and I are relative newcomers to the IETF community, so what we are grateful to all of those who have engaged with us and provided us useful feedback so far, and we look for even more of that. And then finally, we'd also like to just achieve wider adoption by existing PGP tools, and much of the PGP community also is in the IETF community. So those are the 5 major points of development. And of course, eventually we'd like to push this out either as an experimental draft or an internet standard. And we're hoping that we can be dispatched today. Thank you. That is all.
Thanks, Miles. We've got a couple folks in the microphone queue here. So Ecker, please.
Hi, Eric Scorla. I have a potentially dumb question. You said so as I understand it, the key list contains the fingerprint of the public key, right? And you said you can update your key. How do those work together?
Right. So the key list contains a fingerprint of the public key. So let's say I have a private key. Yeah, if we go to that slide, thank you. So my key, you'll notice it's the second one. What I can do from my computer is because I have the private key, I can update my key and then push it to the key servers, and that fingerprint will not change. So, because
sorry, this is DK. Can I just offer a clarifying thing that I think maybe Ecker had missed, which is that this is a fingerprint of your OpenPGP. When people say key here, it's confusing because the OpenPGP terminology is confusing. This actually represents the fingerprint for an OpenPGP certificate, which is also known as a key block, also known as a transferable public key, which is an internet standard, which is RFC 4880, which can be updated by adding subkeys, by changing expiration dates, that sort of thing. So this points to and identifies a certificate that can be updated without changing the fingerprint.
It's the root of some chain of trust.
It's the root, yeah, effectively. So, if you want to change which transferable public key this points to, you have to update this. And sorry, Miles, I think that wasn't clear for folks who are used to thinking about keys from like an X509 perspective.
And DKG, while I've got you at the mic, is there a need for hash agility here?
This is DKG at the mic. I do not. So there's been a lot of back and forth about the way that OpenPGP fingerprints are formed. This draft is not the right place to do that. We should use whatever if this draft goes forward here at the IETF, we should make sure to use whatever the OpenPGP fingerprint standard is.
Mr. Kadek?
Ben Kadek, so I was taking notes. I have a few questions. First, you sort of mentioned that web key distribution is not usable for your use case because you've got all these people that have keys at different domains, and the domains don't have a common administration. And you also mentioned that you have lots of other organizations that are looking at this. So I was kind of curious if these other organizations had the same property where they have these multiple domains for the keys, and so they can't use WKD.
If I may, I'd like to let Micah answer this question because he has been at First Look for a while longer and oversaw the initial development of GPG Sync. So Micah, if you could join the discussion.
Yeah, so I see Micah in the queue. Robert, Miles, I'm going to have to eliminate you from the queue, I think.
Yeah, I think you have
Feel
to
free to join afterward.
That is fine. Thank you.
Hey, can you hear me?
Yes.
Okay, so with First Look Media, that wasn't really an option because we have like several different domains internally. We have like firstlook.org and theintercept.com and fieldofvision.org and stuff. I think that might be appropriate for some other organizations. Like there are many organizations where everyone has email addresses at the same domain, but a different issue is that if your organization starts growing and getting to be bigger, it still is kind of hard to scale people posting updates to their own keys. So if you have like 50 people and someone's key expires and they want to update their expiration date and push it, with WKD, they'd have to update their expiration date, send a copy of their new updated public key to the administrator to post it to the WKD directory. So
okay, that clarifies. Thank you. So my next question sort of relates to what exactly is being signed. So if I can pull the example back up, I think it was in one of the slides. So you got the metadata with the signature, and then the array of keys has the key fingerprint, but also a field for the name, the email, and a comment. And so, like, are we claiming that this signature from the authority key is like being authoritative for the actual name and email address, as opposed to like the actual PGP key has its own signature over the name and email address? And like, are we supposed to trust both of them or just one?
You're supposed to only trust what is in the what's in the actual public key block. The name and email address in this are optional, and this is basically just to make it easier to read the key list. What's actually being signed is this entire JSON block. So this is like a file that, and then there's a detached signature file, and you have to have both of them. And if you want to, you could add more metadata to this file, but if you want to, the only required field for each item in the keys array is the fingerprint field. Yeah.
Thanks.
This is DKG again. I'm resisting the urge to get into the details here. I think this is an interesting solution to what I do think is a real issue for organizations that want to adopt protected mail. So I would like to see work on it. I just want to observe from a dispatch perspective that this seems to depend heavily on the existence of the public key server network. And as someone who operates one of the key servers in the public key server network, I can tell you it is an unspeakable disaster right now. The key server network is not healthy. It is not designed to withstand attack, and it has recently been attacked by people who are desperately trying to prove that it can't withstand attack, and it can't. And so I don't know that the key server network will persist in its current form. And so if this work depends on the key server network, which is not an IETF standard, and is possibly not going to be functional even 2 years from now, then we need to make sure that we think about that for how we dispatch the work.
And before you get off the stage, since you were signaling interest, do you have a preference on how we dispatch it?
I am ex-co-chair of the OpenPGP working group, which failed to get a revision to the OpenPGP specs out. So that would be the natural home for this, but the working group got closed for failing to get that done. So I don't know how to dispatch it. Sorry.
And I think that that's a good point about this relying on the key server network. But like Miles was saying, that really it just needs to rely on some type of way to fetch keys, so it could be from WKD or other methods as well. But yeah, there isn't. But like, if the key servers are really is the only way that GPG Sync implements it, and yeah, there needs to be some public way of fetching keys. Like, it could be from, you know, Keybase or whatever, but there needs to be something.
Yeah, so whatever that other something is, if we decide that the key server network is not an option for making this viable, might make us decide a different thing about dispatch. That's all.
So to reiterate the kind of the back and forth in this conversation, that's pretty much saying if the initial feedback is interesting on the draft, but we have to pull more threads than just this draft if we were to proceed forward. We need to discuss the robustness of the key infrastructure, of the key servers.
I think the draft as it stands does depend on the key servers. Or as Micah said, you have to get it from somewhere, and the only somewhere that's been defined is the key server network. And I'm just giving you a warning and a heads up that I suspect the key server network will not survive.
I mean, it seems like that potentially, while giving up a lot of flexibility, that could potentially be resolved by actually just stuffing the keys into this list here, right?
So that was Ecker saying that. And I wanted to, can we go back to the slide that said why we don't just stuff the keys? There was a couple different arguments for why. So your final argument, I can't address. I think that's correct. And the top one, it obviously just doesn't work for the use case you're talking about. As far as GNU PG key rings, there is an internet standard. There's a cross-compatible internet standard, which is just the transferable public key itself. RFC 4880 actually says transferable public key packet sequences may be concatenated to allow transferring multiple public keys in one operation. So that is what the original the original GNU PG key ring was, is just a concatenated series of transferable public keys. And so that would be possible. That would be a way around.
And that's actually something, it's not in our draft yet, but we're discussing making it optional to include a copy of the actual public key inside the key list. Basically making it required to include the fingerprint, but optional to include a copy of the public key. But you know, so with the First Look Media key list, we have about 230 fingerprints on it, and there's a lot of people who fairly routinely update their keys, mostly their expiration dates, but occasionally add user IDs or other things like that. And it would basically, you know, require way more updates to the centralized key list each time any little change happens if we like had to do it. So we're not doing that now. But I mean, if key servers are completely broken, then, you know, that might be a way to move forward.
This is Oak Squirrel again. I'm trying to wrap my head around the semantics of this object. Namely, it's signed. What is the signature attesting to?
So the purpose of the signature is to make it so that, okay, so this object is at a URL somewhere, and people's keylist clients like GPG Sync download this URL, download the signature, verify it, and then import it. The purpose of the signature is so that if there's like maybe the server on the internet that you're downloading it from is hacked, and an attacker tries to replace this key list with a different key list, it prevents the attacker from being able to put an arbitrary set of keys on everyone's computer, basically. Like, the idea is it's centrally managed, and this proves that you know, whoever has the authority to manage it can post updates.
Yeah, Ben Kaduk again. So I guess my take on this was that what's being, you know, signed or attested to is basically these are keys you should be interested in, and like they're probably people who are in your organization, but you're going to have to use the actual keys themselves for trust decisions about your communications and code signing and whatnot. And DKG is reminding us that we should not have the actual like technical discussion here. So I'm trying to refrain myself.
No, I'm just trying to understand what the point of this is.
So while I've got the ADs at the mic, yeah, so let's try and take a cut at making a dispatch decision here. So this seems like a pretty well consolidated piece of work that it might not need a whole lot of iteration before publication. Is this something that seems suitable to folks for AD sponsorship? Just to propose an outcome here.
Do we want to ask if people are interested in having the IETF do the work first?
Sure. Does anyone else in the room want to speak up in favor of the in favor of doing this work in the IETF, or people who are concerned this is not good work to be doing in the IETF? Not seeing anyone at the mic. No one leaping up. Is anyone besides the authors interested in this work? Okay, seeing 4, 5, or 6 hands. Okay, that seems positive, and it seems like a positive indication of some interest in this work. And I'm not seeing anyone saying that this shouldn't be done here. So that brings us to the question of how to do the work here. So we're back to this question of should it be a working group? Should we AD sponsor it?
Well, someone who would not be having to manage the working group or AD sponsoring it. I mean, that does not seem like enough critical mass or working group at this point.
Okay. So I think
maybe disagrees. Like it's his problem, but it's my
So DKG is pointing out, without standing up to the mic, that there's discussion going on the Open PGP list, which is pretty active, and there's getting actual discussion there. I mean, I agree with Ecker that the activity here is not really enough to spin up a working group just for this, but it seems like we might still be able to get enough review to still publish the document.
Right, Leif Johansson. So I agree with what Ben said, but it's a little bit too bad because there are a lot of subtlety in sort of this kind of bag of keys approach, like around what's the semantic around expiration and how long are these valid, right? What does it mean when an entity used to be part of the list and now isn't, right? Stuff like that has applicability. Abstract model has applicability in a bunch of places, and it's actually been tried in the IETF before. There's an approach for managing Ppp Bdp keys that's sort of similar in semantic, actually. So you have a bag of a bunch of keys and sign them, right? So I think it would have been a good idea to have a working group actually look at this a little bit more generally than just PDP. But I realize it's not going to happen right now.
Our incoming AD.
Roman Dinelio as incoming AD. I'm with Ben. I want to see a little more discussion about the edges of this work on the Open PGP mailing list, and then we can make sure we have the balance right and figure out what to do.
So Roman, you just said on the Open PGP mailing list.
On the IETF PGP list for openpgp at IETF.org. That's the mailing list.
So you said it. You're good. Yeah. So is it X working group? So if I may suggest the summary of this, that the authors continue to discuss the Open PGP mailing list and refine this proposal, and when they feel like it's sufficiently baked to be publishable as a standard, they bring it back to the ADs or to SecDispatch for publication of the RFC.
All right, that sounds good to me. No takers. Thank you for taking that down. All right, Micah and Miles, thanks for your time today.
Thank you so much.
And next up is Andrews for GCS.
Some of you have already heard this talk, so maybe you can sleep a while. It was a little bit interesting to hear about this PGP key list because they mentioned detached signatures. In my opinion, that means that they probably need canonicalization as well, because how can you do that without? Okay, if you want to try something of what I am talking about today, you have a URL, this mobile PKI. You can play around to see that it exists and how it works. You can test the boundaries of it, and you can of course read the internet draft. Okay, something happened? No. We've been hacked. It's something wrong with canonicalization, I'm sure about it. Okay, we are back. Can we have a full screen as well? Okay, almost. Okay, canonicalization can be done at different ways. One is to do it on text level only. I skipped that idea because essentially you get two streams. When if you would first you would parse using your regular JSON tools, and then you would have another line where you do the canonicalization. That is technically possible, but it would integrate very poorly with existing tools. The idea with this system is that it should integrate into existing tools with ease. This picture shows what canonicalization does. It changes, it normalizes numbers. When I started with this a long time ago, I thought that must be very easy to write a number. I was totally wrong. It's rocket science. Fortunately, I met a few rocket scientists that fixed this problem for me, which I definitely could not do. Fixing string, normalizing string stats is, however, completely trivial. Sorting keys in alphabet lexicographic order is also trivial. That's nothing. What you end up with, at least if you follow the draft, is a limitation. JSON numbers must stick to IEEE double precision. That doesn't mean that your application is limited by that, but using the canonicalization system, you must stay in that limit. Ideally, you should canonicalize all data. That means that people put things into JSON strings, like date types, big numbers, etc. But in order to do that, you would have to define a strict serialization of all these data types. That falls outside of what we are interested in. We are only targeting cryptographic operations, and for that you don't need to do full canonicalization. We are satisfied with doing hashable JSON. However, it's not, this is what this picture shows essentially the only snag I am aware of. And that is that if you parse something like this date stamp, and then you serialize it, it must be serialized as this in the same way. And that may affect some applications, it may affect some parsers. But if you know this, you won't have any big problems at all using this system. The motivation behind this was, as I go back to the first page, is to not have to put everything in base 64. One of the reasons is that I'm working with financial applications, and the financial people, they are sort of unused to base 64. They don't want to see payment requests or things like that in base 64. They don't have to. And my mission here is to see if there's any room for this in IETF, with a goal of making some kind of standard. That is essentially what I have to say about this. It has been a multi-year research effort, and I think it's concluded now. It's implementation, adoption, and standardization that's left.
Hi, I'm Watson Ladd from Cloudflare. I would just like to note that ASN1 in one of the canonical representations should be deserializable and reserializable before you verify the signature in a X509 certificate.
Yes.
In practice, this is completely untrue.
Yes.
You have to keep the raw bytes around and verify the signature on the raw bytes of the to-be-signed certificate.
Yes.
And so I'm very, very worried of this actually working. I understand.
I understand. Well, if you stick to what I call native JSON, that means the literals, the true, false, null, the strings, and the JSON number, I would say it's a completely solved problem. It actually works. it works like their encoding should work in ASN1, but I know that ASN1 is a much more complex system. So I think that the slide that I have now shows the only known problem with this system.
Matthew Miller. I mean, so we did have some of this discussion earlier today in dispatch for people that were there. So this is me partly reiterating some of my concerns from there. Like,
sure.
I think for what this is doing, it's probably not harmful, but there are implications to doing canonicalization, and I think if we're going to do this work, we need to understand the shape of those before we try to standardize anything around this.
Hi, Yoav Nir. So anything you can canonicalize, you can then hash, and you can then send a signature without sending the raw bytes, and it's all great. But why is it here? I mean, if you canonize email, you get hashable email. Due to HTML, you get hashable HTML. We don't really expect all of these things to come into SecDispatch and in general security area working groups. So why are we at SecDispatch rather than at dispatch?
I have no opinion exactly where this belongs, but to me it's designed to be a building block of secure protocols. So therefore, and the application is hashable JSON rather than canonical JSON. That's the reason. And so it's mainly an interest for people working with secure systems, at least as it stands today.
I think the current use case that you're looking at is maybe related to security, but canonicalization and hashing is far more generic, and there are lots of protocols around.
Sure, sure. It's not a cryptographic protocol. It's just a building block that could be a part of cryptographic system. You know, your JVS container, for instance, you can open up that and make that readable using this system. I have done that, and it works fine. You don't have to have a base 64 encoded container for signatures.
Brett Jordan, thanks for doing this. I fully support this work. I know a lot of different groups that are dependent on some of this working and being made available. I think it is very important that it gets done here in the IETF so we maintain control over it, and it's really great. And I noticed that you've done a lot of implementations in various programming languages, and they all work. I've gone through and tested some of them. So yeah, I think this is very important, and I would really like to see this take place. I know there's projects that I work on in the IETF and outside the IETF that could make use of this and need this. So thank you.
Thank you.
Eric Criscola, no formal status here. Yeah, I'm not super enthusiastic about this for several reasons. I said some of these things earlier in dispatch, so maybe I'll be shorter this time. First of all, the motivation for this seems extremely weak. The motivation, as far as I can tell, is people don't like the base 64 encapsulation. Doesn't sound like a very good reason at all. And we deliberately, last several times we tried to design secure container formats, we deliberately avoided canonicalization and deliberately go on with data preserving transformations instead. Precisely because every time we try canonicalization has been a debacle. It's not just a matter of whether you can canonicalize or not. It's that people sign the non-canonicalized format a lot of the time, and then you end up having to not use the canonicalized format because even though the canonicalization should be trivial, you end up with non-canonicalized signatures. Second, it's actually not desirable to have the raw data and the signature intermixed, because it encourages people to make use of the data before the signature validation transfers happened. So that's actually quite undesirable. So generally, I think probably this is not actually something we should be doing.
I see.
Hi, this is Sean Turner. So I think there's dragons here from a number of perspectives. One, JSON I think is not really owned. It kind of is and it kind of isn't by the IETF. There was a JSON working group. There was a JSON BIS working group. I don't know, Matt was there. There's a whole bunch of history for people who talked about canonicalization. And I think that consensus of the JSON working group was they didn't want to do canonicalization. So if you're going to do this and take this on, you're going to have to talk to the art guys to make sure that we're all on the same page. Otherwise, I think we're just going to be in an endless disaster with people killing each other over these specs. And Matt probably can add a lot more context to this.
So Matthew Miller, one of the former JSON and JSON BIS chairs. I wouldn't say that there was consensus not to do it. I would say that there was absolutely no consensus in any way, shape, or form to do anything here because there were so many dragons and nobody could agree on what could be done about them.
I understand. Well, you have to trust me that the work has been done to sort of research the issues around this, and they are clarified in the draft. You are free to find holes in the specification, of course. That's very important. But I claim that the problems and the solutions are here. They are already documented. They were not available the time the OC group started. Nobody had done that work before. And actually, I got the information from people in the OC group about numbers, which was the most complicated part. It was said that it was impossible, but it's not.
So
it's a public algorithm that does this.
the folks who keep comments brief, we're coming up to time here.
Right. So I want to add my voice to Eric's point. I don't think it's a question of whether you can do this, even do it safely. I think it will encourage people to use data before validation, which is sort of where a lot of the bugs in the XML signature comes from.
I see.
Carsten Baumann, as I have said in the dispatch working group already, this is three different things. One is define the data model of JSON, which is not defined at this point in time, which is a really good thing to do. Second, define a consistent or deterministic mapping from the data model to text strings, which once we have figured out that we really have it, is also a good thing to have. I have use cases for that. And the third thing is define security protocols that make use of that in one or the other way. And I know several security protocols I don't want to do on this, based on this, but I really want to have the first two things. But those are really application area things, not really security things.
Yeah, thanks for that segue, Carsten. We've discussed a little bit among the chairs here as this discussion was going on. It sounds like there's pretty good agreement in the room here that this is not sec area work. We shouldn't take on any work in the sec area for this, but there may be some in the art area. There's some interest. So yeah, we like screwed this up and we had it in the wrong dispatch group. So yeah, I'm going to say, unless people object that our dispatch outcome here is no work in the sec area, but feel free to try with dispatch.
Okay.
Sorry,
Okay.
we got you the wrong way around this time.
Okay, no problem.
Thank you. And David, you're up.
Hi, my name is David Skenazy. I'm at Google, and I'm here to talk to you about MASK. So first off, apologies for the very convoluted acronym, but I thought an acronym would look cooler. This is very much not a full-on, oh, we have all this work that we're absolutely doing, we want to do it in the IETF. This is very much more early stages, more of a thought experiment of something that I've been toying with for a few years, and kind of thanks to a few smart people in Bangkok came up with a way to do something, and I wanted to present it here to have people tell me either on one end of the spectrum that they're interested and that this is useful work, or on the other that I'm horribly wrong and that I'm going to do terrible things. Because at the end of the day, I'm kind of rolling out my own crypto, and it's totally fine. I follow cryptographers on Twitter, so I know what I'm doing. All right, so what's the idea here? As I'm sure you all know, internet censorship is on the rise. There are more and more instances of governments and other parties getting cleverer and cleverer about ways to either block access to things or to detect that people are accessing things on the internet. And I personally feel very strongly that we should fight that or give people or ways to go around that, especially, you know, journalists and people doing things that we think is for the ethical good. So in particular, a lot of these systems will go out of their way to filter what you can access by like IP or SNI, and will block any kind of technology that works around. So they'll detect IPsec, ESNI, DOE, and block these. And the way these work is that any traffic that sticks out that doesn't quite look like web traffic is just either completely blocked or logged. And then you get a nice visit from government officials that have your best interest at heart. One of the ins that I think we still have is that the internet is still a very, very big place. And so it's very hard today to mount a whitelist, like as a government, of what websites are allowed. So most informants are blacklist based or heuristic based. So the goal here is to come up with a way that anyone who runs any website can run this kind of VPN server on it, and that won't necessarily land it in the blacklist because it is hopefully very hard to detect. So that's where we're starting with this, to come up with a way where I can run a VPN on my personal website, and and I want to really raise the cost for a government actor to detect that I'm running this VPN. So in terms of a threat model, the main threat are passive observers. So let's say this government has a tap in the ISP and can see all the packets going back and forth. So we can't have any information in plain text because they'd see that. But also we want to protect against active attackers, meaning there already have been papers showing, prior research showing that some of these entities will actually do active probes. So for example, let's say they see traffic to my website, they will try VPN protocols to my website, and then if they detect that I connect, then they'll block my website. So there's been a problem with for Tor, for example. So we want a way to prevent those kind of active probes from detecting anything. So I'm going to go through a list of requirements for what specifically I focused on and to kind of bound the scope of this. So kind of went over this a little bit. It needs to really be hard to detect this, so nothing that sticks out. So the SNI needs to be the same as the website you're talking to, but also the ELPN, because both of those are being sent in the clear today. And I know ESNI is a good solution for these things, but because of the way ESNI is currently designed, you can block it by just detecting that extension. ESNI in and of itself sticks out today. So for the same reason is that we can't add any TLS client extensions because those would stick out, or any quick transport parameters because those are also sent in the clear in the client hello. Another requirement is this impossibility to probe. So one of the why this makes it a little harder is that a lot of cryptographic protocols rely on like signing a nonce. And therefore, for a lot of them, you start by getting the server to tell you a nonce and you sign it, but you haven't authenticated yet. So you need to do this without having a way to ask the server for a nonce. So we'll see how that factors into the design later. And another one is, even today, and not for necessarily censorship means, a lot of networks block quick or just any kind of UDP. So this needs to be able to fall back to something that looks like HTTP2 instead of HTTP3. When you're doing that, performance will be worse, but that's a fact we can live with as long as it doesn't stick out and is not noticeable. So now going more into the mechanism and how this works. So you start off by having your client initiate an HTTP3, so HTTP over quick connection to the server, and do a regular handshake, validate the certificate. So for this, you can validate via the web PKI, but you can also, in the client, since this is running a custom client, pin the cert. And so we don't need to build a new authentication mechanism for the server. We already have a very robust one for HTTPS. Let's just use that. Then, because we can't request a nonce from the server, the clever trick there is to use a TLS key exporter to generate a key between both sides, and you actually use this key as a nonce. So this is very similar to token binding in terms of the mechanism, but very different in terms of what it tries to achieve. because so it grabs this shared secret between the server and client without any explicit communication between them. And then you have a nonce that the server has de facto added entropy to, so it's not replayable between TLS connections, but that the client can still use. And then basically you sign this nonce. So you then send an HTTP connect request inside the encryption, and you connect to a specific mask protocol. This is very similar to how WebSockets work for HTTP2. So instead of connecting to a further host, like Connect was designed for in HTTP1, you say connect to this protocol, which is just allows you to switch this byte stream to a different mode of communication between the client and server. And as part of this, you can pass in a username and an OID for which kind of either asymmetric signature you want to use, or HMAC if you want to use symmetric keys. Because I had some people reach out to me that their deployment model couldn't use asymmetric keys, so this also works for symmetric keys and hashing. And you base64 encode all these things, because HTTP is great that way, and you just send that up to the server. And then if the server validates your keys and everything looks good, it sends you a 200 error code, everything's great, and then you have a byte stream to be able to talk mask. Otherwise, it does the same thing that any HTTP web server will do if you send a connect to something it doesn't understand. It sends you a 104 protocol not supported. And so if someone tries to probe you and they don't have the keys, they'll get the exact same response that if they try to send it to a server that doesn't support mask. Then once you have this channel, you can negotiate what kind of mask features you're using. So for example, the simplest one, and I think probably the most widespread, is a connect proxy. So then you've just enabled proxying on that web server. You can connect to any other server on the internet, and that just opens up a byte stream to port 443, and then you do end-to-end TLS. So effectively, you're double encrypting, but then the important part here is the mask server doesn't see the clear text. So for example, on my personal website, I could run this service as like just a favor to some friends in another country, and I get them a way to get around the censorship where they live, but I don't become someone who has access to their private information. They can talk to this like news website that they're not allowed to access at home, but I don't know what they're looking at. I don't know their usernames or password. And of course, that works for any TCP-based protocol. They all can also use it to SSH or whatever. Another feature is DoH. You can just say, okay, well, my web server is also a DoH server. So that gives just private DNS all the way to the client. In today's internet, apart from cleartext UDP, almost all the uses of UDP are connection-based in the sense that you end up sending a bunch of packets to the same 5-tuple back and forth. So in order to make that a little bit more efficient, you do something which is similar to how SOCKS v5 proxies UDP. You negotiate saying, I want to be able to send UDP back and forth to this IPN port. The server says, here you go. And then it gives you an identifier. And anytime you send a quick datagram, which is a quick extension right now, with this identifier, the server just takes that UDP and sends it to that server back and forth. And that allows you to do quick inside quick, or WebRTC, DTLS, any UDP-based protocol that has a lot of traffic. Or a lot of packets between the same 5 tuples. And then finally, if the previous features didn't do what you want, you can just bring up a full-blown VPN here where you just send datagrams with full IP headers, and then the server treats them the same way as, let's say, an IPsec server handles like the inner IP header. It just either forwards them, or you can nap them in such a way that it becomes like the end server, like the really further one, doesn't know that there's necessarily a mask client somewhere. It could all look like it's coming from your server. Traffic? Wrapping up. So traffic analysis is like the main answer I've had from people about, oh, but you can like you're in trouble. And I totally agree. So this proposal really focuses on the bits that are obviously stick out, as in clear text, And I would love help from anyone who's actually really knowledgeable in traffic analysis and the prior work that's been done there. To like, if you want to contribute to this, I would love to, because that is the main risk here and probably the main thing that sensors will be using in the future. And these two things I will skip. I'm presenting this in transport area later this week. We'll also be focusing more on the transport items. So, like I was saying, not really asking for any kind of specific adoption or what to do. Just please tell me if you think this is cool or dumb, or what should I do with this?
Martin Thompson, you should cover it in honey and throw it out the window and see what happens to it. I don't know.
Thank you, Martin. That's helpful.
I don't know. It's a weird question to ask. You actually mentioned a whole lot of things in here, and it seems like there's a number of things that you might work on in this area. There's a lot of existing work in this area. I think we're going to be talking about using QUIC as a general substrate for multiple protocols at some point, mixing them together. We're talking about that in HTTP2 context as well. And I don't know to what extent you're proposing to invent these things and put them under the same banner, or whether you're just talking about one thing. I would suggest concentrating on a number of things and doing some more work on this before we talk about dispatching this proper, because there's this authentication piece that you're talking about, which is kind of interesting and maybe a little more thought out than some of the other aspects of this. There's the integration of that that with all of these other features you talk about is like, oh, you can have a VPN, you can have this, you can have this, you can have this. All of those require extensive protocol work.
Yep.
And that's work that's going on elsewhere as in other drafts and other people working on these things. I would encourage you to work with those people and work out what it is that those things can do before we get to the point of saying, okay, now we want to stitch them together and put together some sort of package that has these sorts of properties. I'm seriously concerned about the encrypted traffic analysis aspects of this one. That is going to be, you can't just go, oh yeah, we need to work on that one. People have worked on this for years.
Yes, that's not what I'm saying. What I'm saying is, I don't know anything about that. Please help me out. Not, we can't solve this. Like,
yeah.
And to your earlier
answer for that one, I think we need some actual work.
No, absolutely. And to your earlier point, I totally agree. I just like had a list of requirements and motivations, and finally came up with a way to kind of tie them in together. But if we were to bring this and actually work on it at the IETF, I totally agree that it would be work kind of all over the place. But I wanted to present the kind of stitched together picture of, I think we can make this work.
We're getting close to time here, so please be brief.
Daniel Kahn-Gilmore. I think there's a lot of really interesting ideas here. I would love to see these ideas go forward within the IETF, possibly in different places, as Martin said. I love Martin's claim that you can't just throw your hands in the air about the traffic analysis and move forward, but it's not true. Like, the IETF has for years thrown their hands in the air and said we don't do anything about traffic analysis. I'm not saying we should keep doing that, but like, clearly you can. But I think that this kind of thing is going to actually impact the decisions that are made on discussions like the spin bit in QUIC, because they will represent radically different traffic patterns. And so I want to make sure, like, I think that in terms of breaking it out, I think you should break out your authentication piece as a first bite. But the traffic flows that are likely to come from this kind of work are going to be very different from the standard traffic flows that you see over QUIC today. And so I think there are going to be impacts elsewhere that we need to think about.
Thank you.
Kathleen Moriarty, just picking up on you saying the only risks and Martin's comments on honey, it seems like, how would I trust the specific servers? That's right for some government agency or whatever to get at the exact point you're looking to prevent, to stand up one of these, capture the server, the traffic, and then the point has been lost.
Absolutely, and that is true of any VPN, and you don't need to convince me, yes, that most of the people selling those don't improve your privacy, but yeah, agree. That's a good point. I will add that to the document. You're correct.
Okay, so it sounds like dispatch outcome here needs more work. So hopefully there's some good feedback there, and hopefully this will keep up some good discussions. So thanks, David.
All right, thanks everyone for your time.
And Next up we have, I believe,
Can I jump
Fernando
in?
Gone. Oh, Ben, did you have a comment?
Yeah, I was just sort of thinking to myself, if we made up a dedicated mailing list to discuss this, can we get like a show of hands of who would actually join that list and participate?
Oh, that's more than expected. Thanks, Ben. All right, I will take the action item of creating a list for interest, and I'll mention it on the SecDispatch list. Thank you.
No, I think the finesse is if you want an IETF list, we can help facilitate creation. You don't need to make your own list.
Oh, sorry, that's what I meant, of putting effort to try to get an IETF one. But thank you.
So, hello, my name is Fernando, and I'll be presenting a document we co-author with Ivan Arce. We had actually presented this document a while ago. I think it was at the SAC meeting in Buenos Aires. Let's briefly discuss what we are talking about here. This document is all about numeric IDs or numeric identifiers. Now, if you look at different protocol specifications over time for the last 30 years or something, many of these identifiers we got wrong. Think about, for example, predictable TCP sequence numbers or ISNs, predictable transport protocol numbers, the ephemeral port numbers. We also did predictable IPv4 and IPv6 fragment identifiers. We also did predictable DNS transaction IDs, and we have also had predictable IPv6 interface identifiers. In most cases, over time, what happened was that eventually the security and/or privacy implications of these suboptimal identifiers, if you want, came into light quite a few times. There were implementation specific fixes for these issues. At times they were suboptimal. And the bad thing about this is that the lessons that were learned from some protocols were actually not applied to other protocols. One example, simple example is fragment IDs. We had predictable fragment IDs in IPv4, and essentially we had the same thing for IPv6. And that's actually still the case. I don't remember what was the last protocol that I had checked about this, but there was a vulnerability advisory like a few months ago. Don't remember off the top of my head what protocol was it, but same kind of thing, okay? So for some of these, for example, Steve Belovin had done work on TCP sequence numbers. I did an RFC on how to randomize the transport protocol numbers. There was some work on them, but it was always fixes to, let's say, float schemes to pick these IDs. What we think is the cause or the root cause of this problem? Well, in some cases, you have specifications that actually under-specify the requirements for these numeric identifiers. So essentially, the spec says, okay, you need an ID there, but it doesn't really tell you, what are the properties that, such ID should have. That's the case, for example, with the TCP port numbers and DNS transaction IDs, just to mention a few. And we have also had specifications that actually did the opposite. So they say, well, you need an ID here, and well, it should be okay if you use a counter, for example. Instead of actually specifying what are the interoperability properties that you actually need for that ID. And then also you have some cases where the spec does the right thing, but then the implementation does not. So what we try to do in this respect is try to prevent future protocols or implementations to actually fall into the same trap, okay? Essentially, well, if you wonder what's, we use or define the term, numeric ID. Sometimes it's what you also call a protocol ID. Essentially, it's a data object that you use, that is employed in a spec to, distinguish one protocol object from another. This ID normally have like different interoperability requirements. In some cases, it could be uniqueness. So you just need a number that is unique. In other cases, the requirements could be things like the IDs being monotonically increasing. And there are others in which the ID is required, for example, to be stable within some kind of context. Also associated with these numeric IDs is a failure mode. So the idea here is, okay, I might have a spec that has some sort of requirements for some numeric ID. Now the question is, well, what happens when those requirements are not complied with? Well, in the case of some protocols, it's there's a soft failure, meaning, well, there's something that fails, but it's very easy and trivial to recover from that failure. Whereas in other cases, we have what we call a hard failure, meaning that things break badly and or takes a lot of time or effort to actually recover from that condition. So when we were trying to find a solution to this problem, one thing that we did is to try to look at different numeric IDs that we have for different protocols. I mean, here we are just mentioning a few. These are actually in the ID, and try to figure out what were the on one hand, what were the interoperability requirements for the IDs, and also try to figure out what was the failure mode for each ID. Okay. This is, well, the list that we came up with, or the IDs that we analyzed. And the reason for which we did this analysis is that we tried to, let's say, produce categories of numeric identifiers, both in terms of the interoperability requirements and in the failure modes. So, for example, here for the IPv6 flow level, the interoperability requirements are that they should be a unique value, but if you happen to, let's say, generate an ID that collides with the previous one, well, there's not much of a big failure, so that's a soft failure. Then you also have cases like in the category number 2, where the requirement is that of uniqueness, but if there happens to be a collision, well, the failure can be actually bad. So that's why we market those as hard failure. Well, there are others that category number 3, the requirement is for uniqueness and for the ID to be constant within some context. That's, for example, the case of IPv6 interface identifiers. And the last one we did was category number 4, which, the requirement is that the IDs should be unique, but they also should be monotonically increasing. And if you fail to come up with proper IDs, there's a hard failure. Now, the point of, producing these categories was to then, come up with possible algorithms. This doesn't mean that it's the only way to do things or the best way to do things, but let's say for each of these categories, we found what some implementations are doing and algorithms that are kind of like, okay. Put another way, if you have a protocol spec, you identify the interoperability requirements and the failure modes, and you cannot come up with a better algorithm, well, at least you have some algorithm that you can employ. Another thing that our document does, besides the analysis that we mentioned before, is to try to come up with requirements for protocol specifications when it comes to numeric IDs. Meaning that if your protocol has a numeric identifier, well, the spec should clearly state what are the interoperability requirements for your ID. Then it should also do a security and privacy analysis of that ID, and then recommend an algorithm. We are providing, some sample algorithms for those. It doesn't mean that, a new protocol spec should use one of these, but if you cannot come up with something better, then you might end up using some of these algorithms that we proposed. We published this document at least a couple of years ago, I think, if I remember correctly. You know, at the time, there was work on 3552-bis. And at the time, we got positive feedback from at the SAG meeting. Among the comments that we got is like, you know, this document had, you know, different kind of stuff. For example, we were doing analysis of the numeric identifiers of existing protocols, and that was kind of like, you know, could be useful as an informational document. Then there was also some other part, like, you know, the algorithms that we were describing that could be like a BCP kind of thing. And then the requirement when it comes to the security and privacy analysis of numeric IDs, which at the time, the idea was to wait for the 3552-bis effort and then try to, you know, see if those requirements could fit in there. But, well, 3552-bis, as far as I understand, was stalled. So that didn't happen. And the other parts of this document were stuck to. So now we keep the original document as a whole thing. We also split the original document into 3 parts. And we are curious, you know, about whether folks find this useful, and if they do, you know, what they think might be a way to actually work on this stuff.
Ben Kaduk. So, I mean, I think it's true that there are definitely several different parts in here that, you know, have different qualitative nature of content to them. And like, there's a lot of sort of historical interest in, you know, how did we manage to shoot ourselves in the foot so badly in the past? And then you mentioned that there might be some parts that are also more of a BCP level. And the main question that I had was, like, what do you see as the target audience for these different documents? Like, because I know you could write a BCP that says, you know, this is what you should do when you're generating your identifiers. But who do we expect to actually read that and take action upon it?
Well, there's this part, for example, which I think would be a BCP, okay? And I guess that at the very least, when you have protocol specs that, you know, work with, you know, numeric IDs, these requirements probably would prevent at least some of the issues that we normally see when it comes to numeric IDs.
Yeah, please. Sorry, this is Denocon Gilmore. So I think one of the questions that you're asking, Ben, is that we typically write BCPs for like operators of these, like implementers of protocols or operators of the services that run these protocols, right? And in this case, I think what Fernando is offering here is best current practices for protocol designers. It's a little bit meta, but I think it's actually really useful for us to think about the IETF themselves as the consumer of the best practices document.
I mean, sure, but we have some things like that are BCPs for protocol designers, and we have a lot of cases when people don't know about them, and, you know, maybe they get surprised by it at ISG evaluation time, and maybe nobody notices, and the best practice is just ignored. Like, we've had this come up with BCP 190 a couple times recently. We've got, you know, BCP 201, BCP 107. I bet nobody, you know, at most 2 people in the room know what all 3 of those are.
So to tee off that a little bit and why I came to the mic is what I was intrigued by the draft is how it took a historical perspective of, you know, design issues, kind of threats, how things were exploited, and then reflected that into protocol kind of guidance. And then kind of thinking big hat, what else is happening in the IETF or in the kind of the broader community is the smart work. And its attempt, yes, there's a lot of talk about malware there, but this idea of taking kind of research and best practice and trying to distill that into kind of protocol work. So I wonder what kind of the audience kind of thinks about aligning more in the IRTF instead.
Yeah, I mean, so Eric Squirrel, I mean, this seems like useful, but I guess I'm trying to figure out why it isn't serving the function it needs to serve presently by the internet draft. I mean, generally these BCPs that we often do are intended to constrain the protocol designers, and the sense in which this is documentation and advice. It seems like people can perfectly well read it in the drafts repository. So I'm trying to figure out why it's not mission accomplished. Drafts don't really meaningfully expire anymore. No, I mean the drafts are like living perpetuity, Daniel.
Watson Lad cover. I really would like to see an RFC that protocol designers don't need to think; they can just cite it and say, "Generate this identifier according to section blah of blah." And I think that would be a very positive step, and whatever process we decide on here should end up with that.
DKG, just responding to Eckert, if we want to have a discussion about the fact that expiration doesn't mean anything, that's a meta discussion. And I don't think that we can say, don't worry about dispatching this because we decided offhand at the mic line that we actually don't care about expiration. I've heard multiple times, yeah, that draft's expired, you shouldn't use it in other contexts. So that's just not, yeah.
Yeah, so what I heard at the mic line is generally there's kind of elements kind of interest. It's, we talked about how to kind of codify all of that, but what I didn't hear other than in one place is that we have to package it up and kind of publish. So there's good kind of design guidance. I didn't hear next step though. Anyone want to fight me on an alternate direction?
I did hear Watson literally say, I want an RFC with a section that I can point to in the next draft that I write. So if you say that you didn't hear that, maybe Watson needs to say it again.
I want an RFC I can point to in the next draft I write.
All right, we heard that. So again, if we pull that thread, does anyone have a proposal beyond AD sponsorship about where an RFC like that could be published? Yeah, how do we get there effectively?
Maybe CFRG. All right, I hear people saying no, but
no. I mean, again, I mentioned SMART. You're mentioning CFRG.
Yeah, I was just saying, the chair here, that the Privacy Enhancements Research Group could also be a candidate group for this. It does, to me, seem to be a little bit more of that researchy character, kind of general considerations character.
One issue with putting it in a research group is that often there's a sense that research groups are not expected to put constraints on IETF work.
Yeah.
Right?
What we think is at least part of the document should be a BCP, so that when you get a protocol spec that has a numeric ID, there's a document that you can direct people to and say, well, how did you come up with these IDs? What are the requirements? Did you do the proper analysis? And if you are employing some other algorithm, well, why are you doing that instead of the algorithms that have been already used for that?
Well, AD sponsorship seems the easy path to go through it. So why are we looking to make something more complex?
Ben Kadek again. So I guess I have to confess, I was trying to do some research on this stuff earlier today, and there's like four documents floating around that I tried to look at, and I ended up sort of a little bit confused about which pieces go where and which things I'm supposed to be looking at. So at least for me personally, it might be simpler to publish the timeline and as informational, that sort of just get some facts out there, and those are easy to check. And then we could be able to leverage that to focus into the other parts of it.
Yeah, my perspective isn't coming AD. I mean, to respond to kind of Daniel, I'd want to decompose what's there back to the properties that are BCPs, the properties that are others. So I struggle to take it kind of as is in advance. documents. So I'd want to kind of poke at it a little more.
Hi, Stephen Farrell. So I don't think you necessarily need to get hung up on BCP stuff, because you can always just put it in an RFC that's informational. And with an RFC 1984, we made it BCP 20 odd years later. So you can just, I mean, just if you want to publish an RFC, if you can find somebody to sponsor it or go to the ISE, then you can get an RFC. And if there's text in there that the community want to turn into a BCP, they can just do that as an action.
So, excuse me, you are suggesting to publish this as an individual submission?
No, I'm saying that there's an option to just not worry about which bits need to be BCP or not, and just find a path to make it an RFC if that's what you want, and you can get people interested and so on. But I suspect if you're going to try and make it a BCP, you're going to have a harder time.
Yeah, so there's like a couple things going on in what Stephen was talking about. So one of them is that you can have an RFC and publish this one publication stream class, and that can be changed at a later date just by IETF consensus and IESG action, I think. And so like you can have a IETF stream informational document that later gets reclassified as BCP. We have done that before. And it's a little bit confusing, but it is an option. And then the sort of other aspect is that, notice that Watson was up here asking for an RFC. He wasn't asking specifically for BCP. He just wants it to be like written down in an archival version of this is the procedure you need to do. And the documents that want to use that procedure can refer to that and say this is the procedure you must do as a normative reference. And like it doesn't matter if it's a BCP or not. Those individual protocols are saying this is what you do, and the procedure that you follow is well specified. And so like that's another reason why the specific BCP label is not necessarily as important as it might seem at first.
Daniel, are you coming up to the mic, or am I wrapping up? All right, so to kind of wrap up, so to kind of pull the thread on the follow-up discussion here, there's some interest. I talked to Ben. What we're going to commit to you is kind of sit down with you to figure out what it makes sense. Do we think one document? Do we think not? And we'll help you shop it kind of in different places, and we'll work towards kind of getting something out there.
Yeah. One thing that we would like to have a real idea about is that the last time that we tried this, well, we had this single document, then we split it, and we got nowhere. So we don't mind which way to go as long as we get somewhere.
Okay, so I'm not tracking kind of some of that history, but maybe we can that can be part of the conversation. Ben and I commit to working that out.
Cool. Okay. Thank you.
Yeah, as you can see, I'm wearing glasses. I'm Carsten Bormann. I want to talk about concise IDs. And I want to do this quickly because John, where is John? Over there? Is going to use the other half of the slot to talk about something completely different, except that it almost looks the same. So I have to do a little work on keeping us separate. So you may be aware about X509 certificates because these have been around for a while, and they are used for lots of authenticated assertions. And what we have now as a new thing is CWT, CBOR Web Tokens, that are authenticated assertions. And they're used for various things. And again and again, the question comes up, I'm using certificates right now to solve problem X. Could I be using CWTs as well? So the obvious question is, can I do that? And actually, it turns out that we have the RFCs in place to do this. There's one in the RFC editor queue, I think. The next question is, shouldn't we go ahead and write a document how to do this? And I'm not even sure it's really normative. It could even be informational because it just profiles what we already have and says how to actually build things that traditionally have been done using X509 certificates, but also can be done using CWTs and of course COSI as a security scheme. So there is this pretty rough draft out there which calls these things concise IDs, because that's the main application we had in mind in the sense of RFC 4949. Identities are sets of attributes, and once you authenticate these, you have concise IDs. So that's an indication of the direction where we want to go, but certainly not the document that we have in the end. So that's one track, and I quickly want to separate this from another track that's also very interesting, which is you could re-encode an X509 certificate in CBOR, and you would gain something. So this is not really compression, it's just a form of concise serialization. So the advantage is everybody already knows what an X509 certificate is. The disadvantage is you get all the baggage of 30 years of using and abusing X509, and you actually need to convert the thing to ASN1 before you actually can sign it or before you can verify the signature. So it's the one thing that we in the constrained environment don't usually want to have. I should have said that we're mostly interested in this for small devices, not just small, but using very little energy, having very little processing power. Unfortunately, there are only about 5 people in this room who want this, and everybody else is sitting over at 6 low. Okay. So this is interesting work, and John will talk about it, but this is not what I'm talking about. I'm talking about profiling CWT for authenticated assertions with a view of having this available in places where traditionally X509 certificates have been used. We had a side meeting about a month ago on WebEx, or it might actually have been Zoom, I don't know, where we discussed where could we put this work. And the problem here is not that we have no idea where to put it, we have too many choices. So the COSI working group could work on this, the CBOR working group could work on this, and so on. But in the end, after the discussion, we came out with 2 working groups that are kind of credible. One is in the security area, that's ACE, which is looking at authentication and authorization in constrained environments. These people are the owner of the CWTs, which kind of was offloaded to this working group because it really is solving a different problem, porting OAuth to constrained environments. But anyway, ACE owns CWTs, so it would be one natural home. And the other natural home would be to do it in a working group that actually has the requirements for using these things. And this is the core working group. And again, there's not really another existing working group that would work here. We could do a new working group, not sure that's worth it. Or we could not do this at all and proclaim that X509 rules. Yeah, well, we probably want to use John's work then, but there is another problem. People are just going to go ahead and use CWTs for these things. And if we don't have a central document from which these applications can benefit, we will get much more diversity and probably also many more security problems. So I really would like to do this work, and it would be interesting to hear whether people think it should be done in ACE or it should be done in core. Do we want to take questions now, or do we?
Why don't we push through both of them and then bring folks to the mic?
Okay.
Why don't we do both presentations?
Yep.
Yeah, so this work is based on a research paper from the Swedish Research Institute. The draft is from Ericsson, Swedish Research Institute, and the Swedish certification authority Nexus. Karsten went through a lot of the reasons why we need this. X509 is big, it's heavy to process, yada yada. This work was presented in Ting to Ting RG, IETF103, last IETF, quite well received, I would say. And what this draft proposes is to do a lightweight X509 certificate encoding / lossless compression algorithm. And the potential benefits and applications of this is to do, it should not be, it's wrong here, it should not be gateway to gateway, it should be gateway to endpoint. So gateway to endpoint compression, when older versions of TLS is used, this is what they do currently in 6LoWPAN. This is not a long-term solution. Hopefully people will switch to TLS and DTLS 103, but devices deployed today will probably be used for 10 years until the battery runs out, maybe even longer. The second thing it could be used for is TLS client to TLS server compression. When TLS 103 is used, we think we can achieve better compression for this type of very constrained ECDSA certificates. And the third application, long-term, would be, as a migration path, would be to completely skip ASN1 and just use this as a CBOR certificate format. And how does this mechanism work? It has two steps. One is a very strict profiling of X509 certificate. And the second is to take this profiled X509 and re-encode it as CBOR. Swedish Research Institute says that the certificates they see in use for IoT is 500 bytes. The profile version is 340, and the CBOR encoder is half of that. So you get very compactness. You get compatibility in the migration path from X509. You get smaller footprint for the compression than general lossless compression algorithms. And the disadvantages is that you still need to support ASN1, at least medium long term, until you switch to a CBOR certificate format. But just the best would be switch immediately, but then you have a hen and the egg problem. Devices will not adopt a new certificate format unless CAs implement this, and CS will not implement it unless devices implement it. So this creates a migration path. I think this is mostly complementary with the CWT thing. I think they should be discussed together. I think it's important that it's done in an IoT-centric working group. The certificate thing would be security. The compression is probably mostly not security.
Okay, interest at the mic, and while the proponents here have both said that they think they should go together, if the folks at the mic line want to suggest parallel dispatch.
Richard, I have not said that.
Oh, I'm sorry?
I have not said that.
I know, but John.
Yeah.
Yeah. So if you want to provide advice to dispatch in different ways, by all means.
Yeah. First, let me tell you a story of a scrappy little authentication format designed about 25 years ago. It started out with just like some names and like a certificate keys and an validity period, and it grew up into what we call X509 V3. So, so I think I'm not necessarily persuaded that just like removing all the fields is going to like end up being smaller, except temporarily. More seriously, I think it's this cannot go into some existing working group. This is the reason we have working groups, is to like actually focus on things that they know about, and not to have this be stuffed in like some like working group that's like doing something else. So taking pictures on merits of this, like maybe the CBOR encoding can be done like in some small corner. The profile of the CWT is like a real security work, and like it's the same order of like PKICs, and it has to have its own working group that's going to proceed.
Kind of somewhat related to what Eku just said. My name's Gary Mundy. I'm at Qualcomm. Both of these mini presentations focused on the encoding aspect of it, but what I've heard a lot from internally in my organization and externally is that a lot of service providers would still be reliant on the existing infrastructure and may not want to actually change how they deal with certificates, and would like to stick to 509 encoding formats. So if you have, for instance, resource-constrained devices that are producing encoding formats like this, will we need to actually standardize how intermediating proxies would work that would accept these formats, yet produce something that's more in lines of a 509 certificate that an existing reliant party service provider would be using? That's my question to the authors.
Well, I have a personal view on this, which is that this is not trying to replace X509 in places where it works well, but it's trying to solve problems that X509 can solve in places where X509 does not work well. So I wouldn't expect a giant gateway infrastructure to spring up for the concise ID work. Of course, John's answer will be completely different.
Yeah, in that case, people who want this compression, they would update the gateways. It would be a new compression algorithm for like 6LOW, and potentially a compression algorithm for the TLS protocol.
Mohit, could you go back to the previous slide? To the one before the, yeah. So I didn't understand this last three bullets, or one of the bullets was that there are devices that are already deployed that use 1.2. So if I'm going to update the certificate format, why can't I just update to a newer version of the library?
Sure, you can update.
Hi, Sean Turner. I want to maybe amplify a little bit what Ecker said about every time we make a small protocol, we then turn around and make it fat. Because there's extension points that are still even in the profile, and I just feel like we won't be able to stop ourselves from extending it and adding things later. On the other hand, like many years ago, I probably would have been up here falling on a sword about coming up with a new encoding scheme. Now, like ASN1 has like 5 encoding schemes. Just do one for CBOR. There's one for JSON. There's one for XML. One for whatever. Like, just make a new encoding format. So the question is whether or not the DER thing is required, and people can get into that argument. But I'm like, as far as the profile goes and dropping out the fields, I think it's so much easier if you just stand on the shoulders of giants, as opposed to trying to selectively pick what field is there and what's not field is there, because you're going to rehash all the reasons why those fields were there in the first place. And you're going to end up probably putting them all back.
Yeah, can I just answer one thing? JSON, if we do this right, it might even work with JSON.
Yeah, no, so I mean, my whole idea is if you just want like a new encoding scheme, like there's basic encoding rules, distinguished encoding rules, packed encoding rules, just make a CBOR encoding rule. Like, just make a new one of those, like whatever.
That's not the idea. So if you're completely happy with the information set that X509 gives you, this work is not for you.
Stephen Farrell. So first of all, good luck.
Thank you. We can use that.
So yeah, I think X59 is a pilot craft that's really old, but it's very hard to do significantly better than it. That you're going to actually replace it or displace it even in smaller kind of areas. So I'm really not clear that this, at least according to what I've read in the current draft, is significantly better, other than in terms of encoding size. So it's not clear to me that and for example, I think to be significantly better, you probably need to have some different semantics, really. So I think there's a bunch of work to be done before you'd know if there's something worth trying to spin up a replacement of X59 activity. If anything ever did happen like that, it definitely should be its own working group. And I think PKIX lasted to like 18 or 19 years or something before it got killed.
Yeah, not too long. All right, the line is cut.
Richard Barnes, a couple of observations here. First, I don't know why everyone's hating on ASN1. Like it's my favorite allegedly canonical format that you can take an object and you can deserialize it and you reserialize it and you get different bytes. I was expecting Watson to be up here because he made this observation this morning in dispatch in some other context. Oh, maybe it was here on time flies and you're having fun. Yeah. So I'm kind of amazed that you think this process will even work. Like this idea that you would recreate the ASN1 from the CBOR and have that be faithful. Like do we have empirical validation that actually works?
Yeah, for sure. But it's a very, first you need to apply this profile to the certificate. So it doesn't work on any certificate. It works on a profile certificate. So it would be a deployment that knows they want very slim certificates. So they order this profile certificate from the CA, which is still a X509 certificate.
Okay, so it doesn't work with like an unmodified PKI.
It works with basically similar to the current profile for IoT. It's a little bit stricter than that, but very similar. Yeah.
Okay, so that was point number one. Point number two, you're probably aware that there's been some work in the TLS working group on certificate compression, which is just using like off-the-shelf zlib or broadly or whatever. Have you done like the comparison to see how your performance is here versus that? Because that seems like much more simpler.
Yeah, I think this is doing better compared to the figures I have seen from the compression people. But that would need to be done before. Such comparisons should definitely be done, not only the sizes, but also what are the code and memory requirements on the devices. I don't have any clear answers. Research Institute of Sweden tell me that this is lower. I believe them, but I don't have any numbers. Yeah.
Thanks.
Hi, this is Henk, co-author. So first of all, this is not about rehashing the work of 30 years. Then I would have to repeat Carsten's comment. If you're fine with that, this is not for you. We have new scopes and intents for these assertion bundles, and a very prominent one is the identity we're talking about. So I'm not going into what is an identity here. It's verified, I hope. But the purpose here is that we start the work. And there is actually, there are entity out there like a CA, like a national CA, that is very interested in this. So just saying nobody wants this because it's changing and hard is, I don't think, a very valid argument. Also, there are stories where I have experienced that trying to use ASN1 again for a different purpose didn't work, while it would have been work from the start when we would have used CBOR. So there is also basically the anti-example for this, that it would have been better to just not use ASN from the beginning and don't use the CMX X509 representation. So that's just all side information on this topic. We are starting with concise identities because people, I think, have a relatively good understanding how to deploy them and work with them. But in the end, these are signed assertion bundles, and not everything here is about identity. This is a first step for a thing that we want to establish here. And it is, again, to repeat Carsten's comment, about the constrained node environments and for future use, and not for rehashing every extension that has been made or created in the last 30 years, because, and now I quote an editor of the dev ID draft, they are insanely arcane laden, and I regret it. So there's that.
Max Pala, Cable Labs. One comment and one question. The comment is, just hearing what he just said and what you said before, seems to me that this is not just a change of encoding, but is let's remake what we did before, adding new, possibly new features, etc. And this could be seen as let's reopen in another way a PKI working group. The question that I have for you is, certificates is one thing in a PKI. There's many other protocols, many other data structures that needs to be updated as well. Are you considering to do all this work? And if it's not an encoding, are you planning to replace current mechanisms with new ones?
Well, just an example, signing request, a CSR, is a CWT, so we don't really need a separate data structure. This just falls out from doing the signed data structure as well. So in some cases, we can just reduce the number of variations we need. But if you're talking about things like timestamps and OCSP and so on, yes. So in some cases, those will be needed. But I think in many cases, they will just take a different form because we have things like authorization servers, authentication servers, that redo these things in a specific environment. So I don't know whether we actually would ever come up with a generic timestamp format, but we might come up with something that allows an authorization server to issue some freshness indicator that can be used by a client or a server to continue working.
Okay, thanks.
Just to follow on that, Carson, I think for for edification to know about knowing his background, there's also co-op EST, right? So there's other things that are going on in that space to kind of handle these additional protocols already.
Göran Selander. So I'm co-author of the CBOR certificates draft, and I'm listening to the discussion here, and I have a general question to the security community about how I mean, these are two examples of people want to make more compact certificates for the purpose of IoT, and we have plenty of use cases where people want to deploy lots of devices using some automated mechanism based on manufacturer certificates, enrolling new certificates while in the network and so on. So this is a concrete problem, and it seems that these people are not happy, not delighted or enthusiastic over these proposals. Some ideas are present, but I'd like to ask the security community at the IETF, where do we go? What do we do? I mean, how do we address this problem? If someone has some guidance here or what we should do, because this is a concrete problem, and even if you don't like these proposals, what's your proposal for addressing this problem?
Yeah, so thank you for the segue, Göran. I think what I've been hearing at the microphone here is that people don't think this is appropriate for kind of the fast path options we have for dispatch, kind of AD sponsorship and things like that. But that there's enough meat here between these two proposals and the general topic of doing more compact authentication to merit above. So I think that's probably the course we're going to recommend. So I suggest the proponents to work with the ADs and see get something set up. All right. And any comments on that outcome? Further discussion? All right. We'll call it dispatch. Thanks, guys. It is. So that is the last of our scheduled agenda. We have about 10, 11 minutes left I've had one request for an AOB slot from Joe Hall. So, Joe, what's the name of your draft again? Oh, it's so. Oh, yeah. Where are the blue sheets? Can you someone bring those forward, please? We've got some folks in the front who need them. Draft all censorship tech.
Cool. So I have no slides. I didn't even know this working group existed until about 3 or 4 hours ago. I apologize. In IETF 91 in Honolulu, we started some work, very descriptive work on an internet draft to talk about techniques that global censors were using against protocols. We had a pretty drafty draft at that point. We've worked on it since then. It's now split up into 3 things: prescription, identification, and interference. You can read it. Prescription is how you decide what to block. Interference is how do you identify what to block. Identification is how to identify what to block. And interference is actually performing the impairment or blocking. It doesn't have to be exactly blocking. It can be slowing down and stuff like that. It's now busted out into layers, and this is with collaborators at Princeton and folks at CDT. The whole purpose of this draft is to be purely descriptive for people who write protocols or implement protocols, that if you care about people in places of power using your protocols in ways you didn't intend or whatever, you can read this draft and get examples of how protocols have been used against users. And so there's a similar draft that I know Richard had worked on that talks about the effect on the internet architecture of blocking and impairment. This is more about the effect to users and the availability of information. It's pretty, so it's been 4 years. Part of what happened is I did IASA 2.0 in the middle of that, and I haven't had staff. Well, excuses. It's pretty mature at this point. There's a couple of open issues in the repository. We're hoping that this is one of a series of descriptive drafts that are meant for IETF, the IETF community, or any protocol designers that identify themselves simply as references to see how people are doing certain kinds of things. And we've had some interest in traffic analysis. There's been some very fledgling pointers at that kind of stuff too. At the time, we had sort of tentative AD sponsorship from Kathleen and Stephen when they were ADs. Obviously, it's been very different from now, and in fact, AD sponsorship itself may have changed. But anyway, and as people have said, this is very useful as an ID as itself. We thought about doing it in an RG in the HRPC research group. At the time, people felt like it would benefit from being an IETF document for IETF folks and going through the IETF process and consensus. Anyway, so I can do a more polished presentation later in the week. Just got to give me sorry, I just didn't even know I was going to do this. I could do it at SAG or for people if you want me to pull you aside and sort of talk about what's going on here. There are a couple of open issues that we're still dealing with, like, for example, all of South Korea blocking ESNI. That's something that definitely it needs to be in here. I think it is sort of in here, but not in a perfectly polished way. With that, I won't waste any more of your time, and I'm happy to take questions.
Yeah, Joe, real quick. I'm sorry I came in late and missed completely all of your presentation, but
it was very short.
This seems like something that would be good for the PRG, the Privacy Enhancements Assessments Research Group. We recently took on work describing data collection mechanisms and best practices around there, and this is sort of in a similar vein, so I would encourage you to potentially consider submitting there and asking for a presentation next time.
Sounds like a great idea. I don't exactly remember the rationale. People were saying it should be in IETF rather than IRTF. As you can imagine, anyway, but happy to do whatever. Even happy to keep it just like this too, because it's the kind of thing that changes quite a bit, and I'm not so sure an environment that changes as dynamically as censorship, a RFC may not be the best thing as an endpoint for that. And I think in doing the authorship, we've sort of realized that because we have to change it every 4 or 5 months to respond to the actual global internet environment. But yeah, I think that's a great idea. I'll stop.
Yeah. All right, thanks.
Any other comments? All right, thanks for the heads up, Joe. I think there's probably no further action at this meeting, but please feel free to send mail to the list, and we'll see if we can get this dispatched there. All right, any other business in the remaining 5 minutes? course. Yeah, Kathleen reminds me that in our personnel announcements earlier, we forgot to thank our outgoing AD, Mr. Eric Scorlo. All right, that was the last business I had. So, oh yeah, so hold on one more second. So, Roman, wanna? Yeah.
Okay, just to wrap up what we said, I'm reading kind of from Ether. I'm reading from Etherpad here, as we talked about the protocol for OpenPGP key subscriptions. We're going to, the recommendation was to go to the IETF OpenPGP mailing list and grow the interest there. As it relates to JCS, the feedback was to bring to the ART area. As it relates to MASC, I think efforts are in flight to already create a non-working group IETF mailing list to further that conversation based on the interest. On the work related to identifiers, the ADs are going to follow up to think through what the right venue is. And for the last two things we heard, to concise IDs and CBOR certificates, the breadth of the topic suggested BOF recommended. And to the very last talk that we had, we're going to just bring that to the mailing list to further the conversation, and then to figure out what the next steps might be if dispatch is appropriate. All right, with that, thank you, everyone. If someone has the other blue sheet, would appreciate if you could,